Thank you. Our final lightning speaker is Robin Lovelace from the University of Leeds.
Thank you. So, welcome to my talk. Because I've got the graveyard shift, the last of the lightning talks, I'm going to start with a question. So, during the 2020 lockdown, what was the percentage reduction in CO2 emissions worldwide? Anyone know? Guess? 2? Someone said 5. Any more for any more? 6. Bingo! Yeah, so 6% was roughly how much we reduced CO2 emissions during an enforced lockdown. So a great thing about that is that people responded well. They listened mostly to the science and they took action. So that's a good news story. But what percentage do we need to get to solve the climate change issue? 100%. We have to get to zero carbon. So it's pretty clear what the direction of travel is. It's zero carbon is the aim. And I think when you realise that, even under a severe lockdown, unprecedented government action, we're not getting there. We need that 6% reduction year on year on year in every country. In the United States and some Western countries, it was actually more than 6%. I think it was about 13% in the USA. But that gives us an indication of the scale of the problem. So that creates the backdrop. It is an urgent challenge, and even though COP26 is no longer in the news headlines, this is, I think, one of the biggest challenges we will face, and I think urban analytics has a huge amount to offer. And to link that to this slide, which is a brief kind of story about where I come from, I've always wanted to have my work to have impact, and I found over time that not just writing academic papers, but actually building tools, and not only tools, but software and data can ensure impact. So there's some of the logos that demonstrate it, and I think those are academic outputs. And the other thing to say by way of introduction is I should have an opportunity to try and put some of these ideas into practice as I'm starting a number 10 data science fellowship. So that's working in central government to try and support various departments with data science alongside Federico, who's also in the audience. So to go back to the question, how can urban analytics help with this decarbonisation problem? It's about problem solving, and I can say happily it already is helping to solve the problem. This example is taking a big messy data set, origin destination data, open access, and then converting it into estimates of latent cycling demand on the route network nationwide. And this is being used to inform strategic cycle network plans nationwide. But I think this approach can apply to different areas of the economy, but I'm going to focus on decarbonising transport. So what I've done previously is just looking at one mode, cycling, but we need to do way more than getting people on bikes to solve the climate change problem. So linking nicely to Alistair Ford's presentation, if we want to take this forward, it's not just about latent demand for cycling, or it's about how are people going to travel. And it's pretty clear that if you build a housing development in certain places, you're going to encourage certain types of transport. And in fact, it doesn't require AI to understand that. You just need to do some, I would say, exploratory analysis of data to get an estimate of what the mode split of a particular location is likely to be. And this is actually a real location in Leeds. It's the Leeds Climate Innovation District. And it's likely that people are going to walk there. So we can, that around, over 50% of trips that emanate from that new development are going to be by active modes. So that's a positive vision of the future, and we can actually simulate it using these urban analytics techniques. And I think that's a really fantastic thing. Going back to Vanessa's talk and questions about participation, we can also make this participatory. So like many of the other presentations, this is actually publicly available. If you search for ACDev or acdev.sipt.bike, you'll be able to see an interactive website. But I think one thing that's not talked enough about in these kind of data science, urban analytics discussions is actually the data. So I think in this case, the data could be much, much better. If someone wants to think about how to decarbonise central Manchester, for example, which is shown on the map here, what have they got to work with? Well, they've got Google Maps type aerial photography. They've got, if they're lucky, they've got Ordnance Survey data, which has quite restrictive licensing, and they've got OSM data. There are other data sets out there, but I think there's a lot more that's needed. And I think thinking about AI and thinking about how we're using these systems, I think we can make much better use of people as data collectors. As Mike Batty said, they can be ways of improving this open data representation so it looks a bit more like that, but filling in the gaps, and there are still a lot of issues, even with tools such as Dustin's A/B Street. So the data could be a lot better, and I think as an urban analytics program, we can encourage the collection of much better data. We do need better data, and we need better open data. So that's my final slide. I've got lots of ideas for taking this forward. I think the lessons learned during the pandemic, it's not just about how do we prevent another pandemic, it's how do we build a world that's actually sustainable. And this final graph at the top shows data on mobility patterns, and you had a massive boom in cycling last summer, and that is something that we can learn from. I think, yeah, there's many ways that we can mobilize as a community, and there's a lot of ways that data science can contribute, especially as it relates to not just simulating a low carbon city, but also predicting, if you do certain interventions, what's going to happen. And that's something that I'd like to collaborate with people on who are more into the machine learning and modeling side. So thanks a lot for listening, and any questions, chat to me after. Thank you.